Okay.
So let's imagine we had. I'm just going to bring it straight to the solution first for a quadratic equation. So we've got x plus 1 multiplied by x minus 2, for example. Now, we're going to say is greater or equal to 0. So how would that be demonstrated on a graph? Well, first of all, if it was equal to 0, we know that the solutions are x is either equal to minus 1 or x is equal to 2, right? Because either this is equal to 0, or this is if this was an equal sign. So what we learned about quadratics before was that, so in other words, x plus, I might just copy that up. Yeah. So if it was more like this, then either this would equal to 0 or that would equal to 0, right? And if that was the case, then x is either equal to minus 1 or x is equal to 2. So if we plotted the graph y is equal to, all of this here. So if we plotted that graph there, we know that because this would be true for when that equals 0, then that would be, in this case, when y equals 0. So for when y equals 0, then x is equal to minus 1 or 2. So in other words, the point on the graph where y equals 0 is the x-axis. So when you plot a graph, if you were to get a curve like this, then it's going to intersect the x-axis at this point where this would be 2 and this would be minus 1. So that is the graph of y equals all of that. Okay. So how can we now use this to think, well, what is it? How can you demonstrate this? Well, essentially, we're looking at this. So if we look at where I've put the y, then I use a different colour that's a bit more visible. So there's my 0, and there's my y there. It's not a very good highlighter, is it? It looks like I'm scribbling. So there's my O there, and this is the y there, right? So if I wanted to now look at how I demonstrate that it's greater than 0 or equal to it, then it's basically whenever y is greater or equal to 0. So how would I demonstrate that on a graph? I would simply colour in the part of the line where y is greater than 0. So we know that that's going to be this part of the axis here, which means it's whenever it's this part of the graph and this part of the graph. I'm not quite sure what the protocol is for demonstrating if it's equal or greater to this one here, but we know from the number line you would colour it in. So maybe they do something like that again, or you do a hollow circle if it's not equal to it. So in other words, what you'll get is a question where it might be. Is this okay? What you'll get is a question where it won't be in this format. You'll have something like, well, let's expand these brackets out. So we got x squared plus x minus 2x minus 2. So x squared minus x minus 2, and that might be greater than 0. They might be even more tricky than that. They might rearrange it to say x squared minus 2 is greater than x, for example. So then they might say draw a graph to demonstrate the values that x could have. And so what you'd have to do is rearrange it into basically imagine that was an equal sign and sort of solve it, or I guess just factorize it. And so you get it into this format. And then you'd say, well, if I plotted y is equal to that, then I know that I'm going to have x-intercepts at these points. And so therefore, the values of x that y would be greater than is any value less than 1 in this case. So x is going to be less than minus 1, or x could be greater than 2. So that would be the solution to the problem. But the general protocol is to go through these stages and then see it diagrammatically. Now, once you've done a few of these, you can end up doing some of these stages in your head and just sort of imagine what the graph would look like and go, oh, right, so it's got to be above that axis, which means that anything left, because if x was any, if we, let's use a highlighter again. If x was greater than minus 1, it's going to be any of this value here. And for those values, when for x, well, y is less than 0. For values of x where it's less than minus 1, y is greater than 0. So that it meets this criteria. Does that sort of make sense?
Yeah.
Okay, so I think we make